There. And that started. And up here, we'll start this one.
So you could like video your screen and send it to somebody?
Yeah. That's what I'm doing that's what I do every day. But I can do it with Skype also. I'm doing it with Skype. It takes longer to do with Skype, but the reason I'm doing it with Skype is something happens to this recording that I'm doing right here. It's called a screencast. I had to look that up. Then
like with Skype, you can send it to someone.
Yeah. So. What's today? The 4th. Okay. So after I lobotomized everybody the other day, and after everybody wouldn't listen to me, I went and did some research after I got hung over and everything. And I went to several sites and I looked up, I do have some physics books, some old physics books, and I looked them up. And guess what the narrative of all that research said? It said that whenever you have metric units and you're working with force, you need to multiply by 9.8. Now, why is that so familiar? Why does it sound familiar to me?
You talked about that in class.
Because that's what I said in class. All right? Now, why am I kind of angry about it? It's because y'all didn't listen to me. No, I'm just kidding. Every one of the videos that I watched and the research that I did basically said that when you're dealing with acceleration due to gravity, you have to multiply the 9.8 into the metric units. Why? Well, like I said, I'll write this down for y'all, and y'all won't believe me, but, I've done decided y'all not going to believe me, whatever I do. So I'm going to write it on the board anyway, and then I went through and I redid some problems. Redid them right here. I redid some problems, and I'm going to explain them in a different way so that y'all will understand and not be lobotomized after today's presentation. So is that fair? So I took some extra time. That's what happened. I didn't want to teach the other day. That's what it was. And did it go through its thing? I guess it did. Where's the exit? This is state ingenuity. In the houses, if you have 3 lights, usually the light in the front goes with, but in state ingenuity, that's the back light. That's the middle light, and that's...
They got the middle one right.
Yeah, they got the middle one right. Anyway, so why do we have to do the 9.8? Well, of course, we all know that force is equal to Mach, which is mass times acceleration. Now, this came from a physics guru, so don't get mad at me if you don't believe me. Which in the metric system is kilograms per meters second squared. Okay? Which comes out to be kilograms per meters per second squared, which comes out to be Sir Isaac what? Newton. And it was named because he got hit on the head with an apple. Okay? That's where all this comes from. Now, in the SI units, they do it a little bit different. They do pounds times feet per second squared. But in that feet per second squared is 32 pounds. I didn't even know this was in here. Feet per second squared, which when you do the math in the conversion, it comes out to be 1 what? Foot pound. Okay? Now, this is incorporated into the conversion with the SI units. Everybody with me? What is not incorporated up here?
Wait, SI is the metric every customer.
SI is metric.
I thought SI was the old units.
No, SI is the international standard.
Whatever. American units, all right? There, American. I thought SI units was. Anyway, the whole point is, y'all are just trying to piss me off. All right? The whole point is answer one question and y'all worry about this stuff. That's why y'all suck. All right. That's in the conversion. What's not in the conversion up here? 9.8. So, as the physics guy says in his video, whenever you use metric units, you have to multiply by 9.8. Now that the physics guy has, don't you ask a question? No. All right. Now, when you're dealing with force, you have to multiply by 9.8 because it has its acceleration. The reason you don't have to do it for the American units is because it's already considered, it's already calculated into the foot-pounds. Now, what is your question? If it's a physics question, I ain't going to be able to answer it. What?
I was just thinking that pounds already account for weight, while mass doesn't.
You have to ask your physics teacher.
Oh, that wasn't a question.
Huh? Oh, what did you say? I didn't hear what you said. You said something about it. I'm scared that y'all going to say, what is the mass of the earth? Go ahead.
No, I said mass does not account for, mass and weight are different because weight are units.
That's true also, and he talks about that too. After he says, whenever you use metric units, you multiply by 9.8. And the reason I keep saying that is because I watched 3 videos and I looked at 2 books, and all of them said the exact same thing that I said before class the other day. Whenever you have metric units and you're dealing with force, you multiply by 9.8. Now, do y'all believe me? What? What'd he say? You know, y'all can go jump in a lake, all right? Now, we are going to do another tank problem, and this time I hope I can not lobotomize you like what happened the other day. So,
Remember, kilograms and stuff is.
I don't know what I thought this whole time. I thought SI was, but I didn't know chest of drawers was chest of drawers. I always thought it was chest of drawers. So, all right, here's a problem. I don't know if we did this one or not, but I found it, and I hope I can do this one correctly. Conical tank, and I hope I can spell it right. With y'all, I don't know. Conical tank, y'all may find a new way of spelling things, is 18 foot high with a radius of 12 feet. Filled up to 15 feet of water. Oops. They want to know how much work, and most of these problems are going to be the same question. How much work to pump the water out of the tank? Now, when they just say pump the water out of the tank, what they're saying is over the edge. Or some of them might have a hole. Okay? That's irrelevant. Even though to some of y'all, it probably isn't. But in most of these questions, irrelevant. Irrelevant. This tank is 18 feet tall and has a radius of 12 feet. And the water is at 15 feet. Now, I'm going to, from here on out, whenever we're dealing with water, I'm going to use a blue for the water, and that's going to, and I figured this while I was doing problems the other night, last night. While I was doing some of these problems, I said I'm going to take that blue, and I'm going to use that blue for a reason in the actual integration, and I think it'll help you out, because what we're actually finding at the end, remember the hatching, some of y'all remember the hatching that I told you about CAD, when you find the area? Well, it's also with volume. So that blue represents finding all that area. I meant volume, since it's three-dimensional. Okay, and we're going to use the blue in the integration, because I think what happened the other day is I think people started getting displacement mixed up with the volume. And I think that's why a lot of people were getting confused. Okay, so find the volume of the slice. And the volume of the slice, I'll just take a green marker and I'll just put a slice right here. Okay, there's the slice. And the volume of the slice is going to be equal to pi r squared h. That's the volume of the cylinder. And this radius right here is going to be changing, just like this h is going to be changing. So you have to set up your similar triangles. So go ahead and set up your similar triangles, because what I tell students is, yes, go ahead and put this first, but your second step is usually going to be your similar triangles. Because you need your similar triangles to put in for that radius. So set up your similar triangles. So 12, 18, H, and R. And it doesn't matter how you set it up as long as you're consistent. So I'm going to go 12 is to R, as 18 is to H. And solve for R, because you need to plug it in for that. So R, 18R is equal to 12H divided by 18, and R is equal to 4, 5, 3, what? 2/3. Somebody help me out. 2/3 H. And we're going to take that 2/3 H, we're going to plug into that. Those two steps are pretty much generic every single time when you're dealing with a plunger, you know, like push-up plunger. The only time you don't have to do this is when you're dealing with a cylinder, because a cylinder doesn't what? What's different about a cylinder versus a cone? Doesn't change. Huh? The R doesn't what? Change. Okay? Now plug that in, and that's going to be the volume of your slice. So put my green marker back in effect. So the volume of the slice is equal to pi, parentheses, 2/3 H. And what is the height of this guy? Delta H. And the reason I use H is for hair. So people use it for height. It doesn't matter. In other words, that slither is the width of a what? Hair. So delta H, which later turns into DH, which doesn't really matter, but there's your pi, there's your radius, and there's your height. So that's your volume of the slice. Now, circle that because you're going to use that to find your force, which is volume times what? Write this down. Force is volume times what? Density. And that's where you pull in your 62.5. Now we're still in green because we're finding the force of the slice. What do you mean the force of the slice? The force to pick up, to push that slice. You with me? Because what the actual integration does is multiply this slice, just like the hatching, thousands, millions of times to find the volume of what? Of the water. So the slice 62.5 times pi times 2/3 H squared delta H.
Where did you get the 62? Yeah.
What is 62.5? Density of water.
Oil or something would be different.
What?
Yeah, like
OIL, yes, be a different number. However you pronounce it is up to you. But I guarantee you somebody will say it's incorrect. 62.4, 62.5. Maybe it might stop the revolution of the earth, okay? Revolving of the earth. It might. I don't know. Oh my gosh, I used 62.4 here. That means that the earth is going to stop revolving.
It might only slow down. It might not stop.
Y'all are starting to pick up on my sarcasm, are you? I think you are. All right, so now, what you're going to do now is you're going to take all of that and you've got, I'm going to have to go, no I'm not, I'm going to do this. Really? There. Oh, come on. Why is it so difficult to do something on this software?
might be operator error.
Okay, you come up here and do it
Control C.
Yeah, I'm about to Control C. There. Now, force of the slice, we'll do it in green, is equal to 4/9 pi times 62.5 or 62.4 h squared delta h. That's what I just did on the other side.
Where'd you get the 1 divided by 9?
Where? I'm not going to answer that question.
Square 2/3.
2/3 quantity squared.
Oh, I didn't get square.
Okay? And that is a common mistake that people make. Now all you have to do is multiply by the displacement. And I think that's where everybody was getting kind of mixed up the other day. The displacement is actually going to have to do with this number right here. Why?
Because that's how to get all the water out.
Okay? Because your plunger is starting right here. Think of your push-up. And it's going all the way to the top right here. But you can't just say 18 feet. You have to do because this thing is doing what? It's rising, so it's changing instantaneously. So that means 18 minus what? Well, whatever you call this, we're going to call this right here H. Some people call it Y, some people call it H. So 18 minus H. So what I want to do is we'll do that in red. Okay? So in our handy dandy page here, I'm going to write, technically we're still dealing with the slice. So we're going this, so force of the slice, or work, well, this is going to be the work. Well, I'm going to rewrite this, 4/9 or 4 pi over 9 times 62.5 h squared delta h. And then I'm going to put the work, or the work of the slice, in red. Is going to be this times the displacement, which will be green, 4 pi over 9, 62.5 h squared delta h by the displacement, which is 18 minus h. Now, that is the work for one slice to be pushed from the bottom of the tank to the what? Top of the tank. Now to add the blue, because the blue is figuring out the whole thing for the blue part of the water. And that's where this comes into effect. Okay? And that's going to be from, how much water is there? Say again? 0 to 15. Because you're figuring that mass not mass. I may be using the wrong word. That volume of water. And if you turn back to the handy dandy, that's the blue. So the blue is going to be from 0 to what? 15, because technically you're finding that volume with the 0 to 15. Okay? Let me go over it again. The green is the what? The slice. All of this and all of this is what? The slice. And then this, where you start to see the green with the red, is how much work it takes to pick up that slice and move it like this. All the way up to 18 feet. Okay? I'm sorry, wrong color. It's supposed to be green. Green and red. Anyway, this right here is taking this slice and moving here, and 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 here, all the way up. One slice. And then the blue, this right here, is basically figuring the whole thing of what? Water. 0 to 15. And it's saying, you remember finding the area between two curves? Okay, you were finding the area between two curves and you were doing this. You find the intersection point. And you were finding that right there. Okay. And then you were doing the shells. Okay. This right here, the part with the integration is basically, I'm making this three-dimensional. You're finding that water. Not one disc, but the millions and trillions of little discs, the hairline discs that are in that three-dimensional cone of water. That's what this part right here does. How's that? Is that much better? What?
I have a question. I don't think it's anything. Okay, so the 18 minus y, is that the distance from
18 minus h. You better say h, because if you don't say h, the world may stop revolving. You've got to say h.
Right, so is that from like the bottom to the top, like how, like the height of it or whatever? Okay.
So if there was a 2-foot pipe
Yeah.
on the top, then it'd be 0, it'd be 20 minus h.
That's what I was confused about last time because I thought the integration was from the bottom.
Well, by the time everybody got through asking different questions, everybody was confused, including myself. All right, what's your question? Direct your question to me, please. Excuse me. What's your question? I'm going to make sure nobody gets confused today.
The integration. So if the plunger wasn't at the bottom, if the plunger was somewhere else in the water,
Yes, you would start 5 or wherever it starts.
it would just go to the top of it.
But most of we're not having those. All of them are going to be from 0 to 15. Not 0 to 15, 0 to 18, 0 to 20, whatever the case may be.
Is that 18?
We're not going to worry about that frog's rear end, okay? Yes.
That 18 minus h, that's part of the formula for the W slice,
Hmm?
ain't it? 18 minus h.
This right here is how far the slice has to what?
Go.
Mm-hmm. In other words, no, this is how far, let me start, no. This is not going to happen. You're not going to do it. All right? This right here, will it not, thank you, in red, this right here is how far, look at your picture. What does your picture tell you? How far, what?
gotta go.
The plunger has to what? I'm not talking about the bit, the plunger. The plunger has to go from 0 to what? 18. Now, if I had a 2-foot pipe here, the water still has to go. Now, you can't go with the plunger because the plunger can't go here and here, but the water is going to travel where? You can say the water. The bottom of the water. The bottom of the water has to travel from 0 to 18. Bottom of the water has to travel from 0 to 20. Because the question asks, what? To get the water, what? Out of the tank or out of the pipe or whatever. And that's what the question asks.
Well, what I'm asking is, what's your original formula for your W slice? You see what I'm saying?
That's right here. Back up. I thought I had it. Right here. Next page. Nope. The force of the slice right here, and then the work of the slice. The work of the slice is right here. There's the work of the slice. What's work? What is work? Force times what? Displacement. Distance.
That's what I was wondering about.
Then what is the integration? That throws in, the integration just throws in the what? What is the blue?
How much you trying to figure? Yeah.
The water. 0 to, what was it?
15.
All right, now do the problem. Now you're done. I tried to break it up in several parts again. Mr. Schaller, you're usually a good indicator. How was that?
That was very good.
Okay. Yes, sir.
In this class, you recording, right?
Yep.
Where do I go to watch the
Go
program?
to YouTube. Pull up Hubert C. McClure. No, pull up Hubert McClure and go under Math 141. Yes, sir.
Right. You come.
No, I've already answered all the questions. What?
We're trying to move the water. Yes, goes here.
Okay. This is a different problem. We'll get to that problem in just a minute. We're doing this problem right now. Remember, we're not going to worry about the frog. Y'all know what I'm talking about, right? If a frog had wings, we're not worried about the frog bumping his rear end. We're not going to use any ifs. We're going to work this problem, and then we're going to work another problem. Y'all get me in this if world, and we'll be all lobotomized. Okay?
You say you got cameras in here?
I got what?
Cameras.
No. What are you talking about, cameras?
Said you.
It's just recording what's on the screen right here. It's recording the volume. It's recording y'all's stupid questions. Yeah. But it doesn't have your face on it, no. So nobody can identify your stupid questions. I'm kidding, okay?
Better sound so you can look.
What'd you say? Yeah, nobody's going to be able to see you and ask questions. Look at that. Now tell me how is this productive?
I'm telling you, if you did the thing I showed you last
All right, come do it.
I will. I did it last time, and you just quit doing it.
Okay? Do it. Fix it.
Okay. I don't know if I can reach it. Oh,
I just want to move this one down here.
why?
No, I want to move this problem right here. I want to copy that.
Oh, no, that's not, you can't do that. That's not what I was talking about.
Go sit down.
No. Look. Look at me go. Jesus.
Thank you.
You're welcome. Now just erase that little circle thing. You don't
No,
need that.
you do it.
No, you don't need that.
Thank you.
If you'd listen to me.
You did that out of love.
No, I showed you how to do it last time.
Well, I forgot. You know what? I don't know how it feels to be in such omniscience of perfection here. Y'all don't forget anything. Y'all don't forget anything.
Not after we Googled it 8 times.
Okay. Yeah. Well, there's nothing on Google on this thing. I'll tell you that right now. All right. So what comes out? The 4/9 pi and 62.5. All that comes out. 0 to 15. And that comes out. And we've got h squared times 18 minus h and dh. And then we get 4/9 pi times 62.5. And that's going to be 0 to 15 of 18h squared minus h cubed dh. Four times 62.5 times pi over 9. And that's going to be brackets 18h to the third, be h to the third over 6. Somebody help me out. H to the third over 6 over 3. I said 6. Minus h to the fourth over 4. Evaluated at 0 and 15. I'll do 0 for y'all. And that'll be 4. 62.5 pi over 9, 15 to the third power over 6, minus 15 to the fourth power over 4. And if you crank that out, you don't know what to do. I got, when I calculated it, which mine's probably wrong, 661 million, or 661,000, 619.4 foot-pounds. What?
I'll bet the top right. Top right.
Yeah, 6. Thank you. I asked y'all if that was correct, and y'all didn't say anything.
That'd be 6h cubed over 3, right?
Yeah.
No, just
Over
18
1.
No, 18 over 3.
Look here. All right, here we go with our basic integration. 18 h to the third over what? 3. 18 divided by 3 is 6. 6h cubed. So that's right. You still get this answer. I just didn't follow my notes like I always do. That'd be 6. Somebody check my math and see if you get 661,000. Okay, 662,000, close enough for government work.
So what happens to the original change of age? You just plug in something for that, or you?
What happened to what?
It becomes 18 minus 18.
What happens to what?
The change of age.
Right here. You distribute this here. 18h squared, h cubed. Right here. Is that what you were asking?
No, I'm asking about the triangle H, like the delta.
That turns into delta H.
Okay.
That's the same thing.
Thank you.
Just when you put it into the integration delta H, they just put a D. Now I can go into the derivation of that if y'all need me to. It takes about a page and a half. All right, let's do another one. This time we're going to do metric. And as I said yesterday, which was last Tuesday or Thursday, when you use metric, you multiply by 9.8.
Why did you do that?
I don't know. Ask Isaac Newton.
Didn't he die or something?
Yeah, he died of an apple overdose.
I don't see how somebody come up with that all in their head.
25 meters
Yeah, I don't know.
and 20 meters. I might have done this one the other day. I don't know if we did or not. And we've got OIL in this one. 10 meters worth. And the density of OIL, given by the problem, so don't ask, is equal to 800. Where'd it come from? Who thought that up? Can you derive that? And they want to know how much work to pump this OIL over the edge of the tank. I redid this one in steps too.
25 is the diameter.
25 is the whole diameter, yes. I don't know. We might need to refer to a physics teacher on that. Now, what I would do is you can set up the similar triangles. You can do either way, but I would set up the triangle as a whole triangle. Like this. 25 and 20, and then the little triangle I would set up the same way. The only difference is this is going to be, instead of R, it's going to be what? 2R or D. But you want it in terms of R, so 2R. You don't have to do it that way. I think I said before I said you don't have to do it this way. I think I said that. Y'all are not what? Listening. You don't have to do it this way, but do we have to do it that way? I don't know. It doesn't matter. The only difference is what are you going to have to do to the 25 if you do it the other way? Change it into 12.5, which gives you a decimal, which says you're too stupid to do it by you have to use a calculator because it's decimals. So
since you're making a ratio, you're kind of assuming that the change is constant, or like the change.
It's called a related what? Say it again. Related rate. Calc 1. Related rate, yes. And that's why these problems are so mathematical instead of physics. They're physics-based because there's a whole lot of stuff that they're neglecting here. But they're trying to reiterate the related rate that you learned back in Calc 1.
Okay.
So this moves the same rate. The height is in a related rate to the radius. Yes. Now, when you get into the physics, that's when they put in all the friction and they put in all the coefficient, the drag coefficient, and they put in all the weight of the plunger or whatever. They do all that. That's why there's a difference between math and physics. there's my slice. Volume of the slice. Are y'all listening?
Yes, sir.
Okay. Volume of the slice is equal to pi r squared h. So therefore, this one is going to be pi r squared dh. And you can put the dh at the beginning, but the only thing is somebody might say, how can you do this without integration? Okay. Actually, when you put it in the integration, the delta h turns to dh. That's when you're supposed to put it in.
Can I ask you,
No.
uh,
What?
so for the top equation, pi r squared h, your h is the change in h, or is it just h?
This is the volume of what?
The slice. So it's just h.
Okay. Not only do y'all not listen, y'all don't what? Read.
Yeah.
Okay. You're trying to, you know what you're trying to do? You're trying to do the tank. You're thinking of the tank.
Yeah.
Stop. You got to remember the chain and the cable? You got to think of the slice first. And that's what we're doing. Slice. So the height of the slice. Why is it delta H? Because that, you got to bring back your limit. It's not this thick. It's what? Hair. And that hair goes to zero. It continues to go to zero, but it never reaches zero. So it's even thinner than a hair.
So dh and delta h is the same thing?
Same.
You just basically change it.
Change it when you go into the integration, yes. So if you want to start from here, just don't tell anybody I told you to. You can actually put it there. Okay? Now, when you set up the handy dandy thing right here, we'll do this in black. You get 25 is to 2r as 20 is to h. So 25h is equal to 40r, so check my math. And I want to solve for r, so that's 25 over 40. R is equal to 25 over 40h, which that's equal to what? 5 divided by 8, 5/8 h. And you're going to take that 5/8 h and plug it in for r. So the volume of the slice is equal to pi times 5/8 h quantity squared dh. And now everything is in terms of what? H. So you need to highlight this as one of the things. This is number one, the first thing you need to find. But to find number one, you have to do what? Number two. So you just found your first part. Now you got to take and multiply by, to get the mass, you take the volume and multiply by the what? Density. So mass of the slice is going to be equal to the volume times the density. And the density of OIL is all that, 800 kilograms per meters cubed. So since OIL is black. I'm going to take this and I'm going to multiply by 800 kilograms per meters cubed, which you're going to see that the meters cubes cancel out and mass is going to be in form of what? Kilograms. The meters cubed cancels out and you're left with kilograms. Not yet, because that's force. Force you multiply by the acceleration. You take the mass and you multiply it by the acceleration. Dang on ma. Force is equal to ma. Mass times acceleration. We just found the mass. Because once I multiply this 800 times this volume of slice turns into what? Mass of the slice.
Force and work is the same thing, right?
Mm-mm. No, you're trying to confuse the class again. Just be quiet. Don't say anything. I'll get to that in just a second. Now, force is equal to ma. So I'm going to take, and we're going to write number 4. Force is equal to mass times acceleration. And what do we use for acceleration when we are dealing with metrics? 9.8. So get to work on that. I want you to do force of the slice and write everything out. You can go ahead and start pulling your constants out and go ahead and start doing that also. Now I ran out of room, so I got it all combuzzled down here. But I've got force of the slice. Really? Force of the slice is equal to, and like I said, I ran out of room, so 9.8 times 800 times 25 pi over 64 times h squared delta h. Y'all check me and make sure I didn't leave out anything. Now, what is work equal to? Force times what? Distance. Displacement. Sorry. $64. What's 8 squared? All right, now I want y'all to finish it out. Since I just told you that this force times distance, that's equal to work, you should be able to knock it out. Now that I've explained to you the 20 minus h versus the 0 to 10. Let me take my handy dandy blue. Let's see if I can. No, I better not try that. Oh, we don't have blue. I'm sorry. Black. Okay, that black area here is going to set up your integration. And I will do this in blue. That black area is going to start at where? The plunger is going to start at what? 0 and go to what? 20. So, when you're doing this down here, here's the force. And I got to go to the next page. Let me see if I can pull a Miss Anthony here. Let's see if I can. Okay, Miss Anthony. Where is the thing?
Like right there in the middle, a little black area.
This thing?
Yep.
That's what I couldn't find.
And click group.
And put group.
Yeah.
Thank you. You are so nice.
I believe that's right.
I'm getting irritated. I'm about ready to tell Mr. Operator Error, whoever keeps saying that. I'm about ready to tell him to come up here and work this that blame thing. I love how they put the dots down here that you need to move. Where do they put them?
Out of the way.
Out of the way. And then you try to move the that blame thing, and it's like, oh no, we're not going to move it. Oh, great. Okay, Miss Anthony, now what?
Well, you didn't get all of it then.
Whatever.
I'm just saying.
Like I said, it must be nice
Oh,
to
you want me to
walk
do it?
on water and
There you go. Okay, see, now you got all of it.
okay, now I got all of it. Thank you, Miss Anthony. I appreciate that. I've never seen it. And then you put the
I
that.
mean, if you could touch the dot correctly, then
Okay, all right. Come here and punch the dot correctly. I want you to do it the first time. I want you to hit it the first time.
I might choose a different one.
No, this one.
Oh, hold on. Oh gosh. Is it some group?
Oh, wait a minute. We're waiting on her. Oh, wait. No, you didn't do it right.
Yes,
It's
I did.
operator error.
Oh, dang it. This is so. Oh,
That's-
I did.
Yeah, she's so excited. It's gonna fail.
I mean, I lifted it up some for you. Oh my goodness.
Do y'all see how complicated it can be?
I got it stuck, so I'll
Do you understand, Miss Anthony, how aggravating this can be? There. Now, after 15 tries, work is equal to force times distance, or displacement, whatever. Okay, we have the force right here. So work is equal to 9.8 times 800 times 25 pi over 64 times h squared dh. That's work. So all we got to do now is erase the work out front. And take our red or blue. And what is that? What is this going to do? It's going to go from 0, it's going to go from 0 to 20, but that disc is at different what? The plunger is going to be at different what? Heights. And you have to put that in there because that's the instantaneous part of the calculus. So 20 minus what? And we're going to put this. Did y'all just see that? There. I don't know what happened there. And that turns into work. Question answer. You asked a while ago.
Yeah.
Yeah, you wasn't paying attention.
No, I was paying attention, just,
Okay. Now what do we have to integrate in? We have to integrate in some more calculus. And this calculus is the black part. Black part right here. As far as looking at this as a what? A milk carton. A volume, a base. We gotta look at that and we gotta push that whole base or milk carton out of this whatever. We've already got the work to do it for a what? A slice. But now we have to put all those slices what? Together. And all those slices together is this right here. This right here, we're going to put a little cloud around this. Puts slices together. Now the reason I'm making a big deal out of that is because with all these 0 to 10s and all these 10 to 20s and all these, what do y'all do as students? You get this confused with what? This right here. Y'all get these two confused. So you need to think, I tell you what, think of putting a stack of quarters together. Stack of quarters, put a quarter on top of a quarter on top of a quarter. That's what you're doing right here. To make this, and when I draw this in circles, I'm not drawing this in circles I'm drawing it in circles to show you the three-dimensional part of, you're trying to figure that volume to push out the top of the tank. So the volume of this black area has nothing to do with that number right there. Because you're stacking the quarters from 0 to what? 10. You're stacking the quarters from 0 to 10. That's this, which is the volume of the what? It's the volume of the liquid.
It's like all the points inside of the volume that are going to be manipulated.
Exactly, that you're going to be what? Pushing. That's what this is right here. And this, all of this, is the work to push one slice from 0 to what? 20. All of this, and you need to put that in here. All of this is the work required to push one slice to top of tank at 20 what? Feet. So, with all that being said, and these two things right here, if you were lobotomized in the last class, then these two things right here, you need to highlight, you need to put circles around it, you need to do whatever you need to do, because you can't lose sight or thinking of the two different things. Especially this versus 20 minus H. So, I got, and this is what I got, 9.8 times 800, 25 over 64, pi, from 0 to 10, of h squared, 20 minus h, dh. And that's going to be, well, I'm going to do a little bit of rounding up because I don't have a calculator and I don't want to rely on one. So that's 8,000 times 25 over 64 times pi. I'm going to go ahead and take the derivative, antiderivative. Multiplied by 20h squared over 2, h to the third over 3 minus h to the fourth over 4. Y'all check me. 0 and 10. Let's see. 4 will go in here 16 times. 4 will go in there 2,000 times. I'm trying to do this without a calculator, so y'all just bear with me. 8,000, 4, 250, be quiet. I'm trying to do something right now. 2, 125. So I've got 125 times 25 times pi over 2. I think I did that correctly. Multiplied by 10, 20 times 10 cubed over 3 minus 10 to the fourth over 4. And this is not going to be too pretty. 3 times 25 is 75. So that's going to be 1,000. That's going to be what? 20,000? 20,000 over 3. So 125 times 25 times pi over 2 multiplied by 1,000, or what did I say? 20,000. 20,000 over 3 minus 100 times 100 is 1 million, right? I can't do the zeros in my head, so 10,000. Is it 10,000? 10,000 over 4. Which that's going to be a mess. When I did the calculations, I think this is the right one. 40 million. Let's just do 41 million joules. It came out to be 40,088,031. Y'all check my math, because I did it. Huh? It's close enough for government work. All right, so let's do another one. Huh? What time is it? I don't know what time it is. Yeah, we got time for one more. Because I got to take the roll and make y'all do something. Let's do this one. And this is another metric, so this is a conical tank. And it's 5 meters. I think I gave y'all this one the other day, but we're gonna do it again. I don't know if I did or not, I can't remember. And 3 meters. Well, we're gonna make it 4 meters. Okay, how about that? And this is 4 meters radius. And we've got H2O in here, and the H2O density is 1,000 kilograms per meters cubed. And they want to know the work to pump that out. So while y'all are doing that, I'll take the roll and then I will show you the setup, because this is the last one I did last night and I didn't do the calculations, so y'all have to do them. And since I changed it, this pretty much this page up here is null and void, so. All right, what day was we not here? That's Tuesday?
Yes, sir.
I need to put, I'm gonna give everybody an absent, I mean, not an absent. What's the opposite? Yeah. I'm gonna give everybody a present. That way, if you missed a couple of classes, that'll give you a.
What, last class?
No, 3 classes ago. Yes, last class. I'm giving everybody a present. That way you won't get a nasty email saying, "We're concerned about you." Have y'all got that email yet?
Yes.
We're concerned about you. All right. Anthony is here. Blair is not here. Blankenship is here. Bolt is here. Brooks is here. Brown is here. Frialdi is here. Hammer is here. Khalil is here. Klutz is here. Loftus. Pickens. Rochester is here. Ryder is not here. Sanders.
Here.
Savasta is not here. At least I didn't see him. Nope. Savasta is not here. Schaller is here. Silver is here. Steedley is here. Street. Swanson is here. You're awful quiet, Mr. Swanson. What's the matter with you? Huh? What?
You keep yelling at me every time I speak.
Yep. You haven't talked today. Trela, Wagler, Waldner, and Warsey. All right. Okay, this one I'm just going to help you set it up because I might as well throw this notes away because I just changed it. But first of all, you need to set up your similar triangles. That's the first thing. Where's my freeze button? I don't know. There it is. Oops. Sorry. Oh, Lord. There we go. So, and usually when they give you a radius, that's when they have set up the problem and set it up like the half triangles. If they give you a hole, then chances are you better do the hole because it'll work out better as far as the mathematics goes. 4, that's 5, and that's 4, and that's H, so it's going to be the same. R, I got R is equal to 4/5 H, is that what y'all got? So that's going to be W is equal to 0 to 4, but I'm going to put everything in here. 9,800 pi 4/5 H quantity squared dy, and what's the displacement? 5 minus what? 5 minus H or 5 minus Y, I'm sorry, dH, 5 minus H. So W is equal to 9,800 pi 0 to 4 of, then 4/5, pull that, what is it, 16/25? 16/25, pull that out. And that leaves you with H squared, so that's 5H squared minus H to the third dH. That's what I got. Okay? So, my question is, how do you feel about tanks now, about conical tanks? How do you feel? Good. That's my whole point. Okay? So, we will have lobotomized class on cylindrical tanks. We'll have that Tuesday, okay? No, we'll be doing springs Tuesday. I will put a homework up. Is everybody listening? I'll put a homework up today of nothing but conical tanks. Okay? Huh? I don't. It's not supposed to be R. I'm sorry. 5. It's supposed to be. I think I don't know.
What did you get?
Hold on a minute. Let me figure this out. Thank you.
Where'd the R come from?
Is everybody okay? Everybody say where'd the R come from? Say it. Everybody say it. 1, 2, 3.
Where'd the R come from?
Okay. Does everybody say it now?
Yes.
Oh, you don't get on my nerves. All right. First person doesn't get on my nerves. The 5th or 6th person gets on my nerves. All right. Now, I pulled that out. All right. Somebody help me. Okay. 5H squared. There we go. How about that? I guess squared, Miss Brown. I guess squared means R. I don't know where I got it. I'm sorry. All right, let me get y'all, some of y'all got y'all's bonuses. But let me do one thing first. I got to shut this off. And I got to shut this off.